That video is getting to be just about 8 minutes, and that's about my limit on videos. So I moved the proof, which is pretty lengthy, into another video of its own. So if we were to look at the proof of the power rule, in order to do that, I want to review a concept first. So we're just going to review before we dive into this lengthy proof. So I just want to review how to factor polynomials, because we're going to need that. So if I were to factor difference of squares, it's just going to be a minus b times a plus b. And if I factor a cubed minus b cubed, hopefully you remember that that's going to be a minus b. This value would be the same sign here. And then I take the first term, square it. I do the opposite, and then it's a times b plus, always positive there, plus b squared. Okay, and then if I want to do a cubed plus b cubed, that's going to be simply a, sign's always the same, positive, then it's going to be a squared opposite plus b squared. Okay, so now say we wanted to get into a to the n minus b to the n. Okay, so then that's going to simply be a minus b. And then you'll notice up here that the exponent was 3, so we subtract 1. So if we were to do it to the nth power, so this could be the 4th, to the 5th, it could be to the 10th, and this formula will work. So you would just take a, and you're going to subtract 1 from the exponent for the first term. Now you don't know how many terms you're going to have in the middle here, it depends on what this exponent is. But in the next one, you're just going to subtract 2 from the a value, but then you're going to be left with a b to the first power. Okay, and it's going to continue. You don't know how many times, but this pattern is going to continue. And then we're going to have a to the first power, but b will be to the n minus 2 power, and then we'll have b to the n minus 1. Okay, so that's an idea. We're going to have to apply this concept and this formula in our power rule. Okay, so in our proof of the power rule, basically what we're starting with is we're starting with the function f of x equals x to the n. And when I take this function, I'm trying to find the derivative of it. So I'm going to take the derivative of x to the n. Well, we all know that that's the limit as h approaches 0 of f of x plus h minus f at x over h. Okay, and then that's going to be the limit as h approaches 0. Okay, I'm going to plug x plus h in. So that's going to be x plus h to the n minus x to the n over h. Okay, now this should look a little bit familiar to this. Okay, something to the n power minus something to the n power. So to make it look a little bit familiar, what I'm going to do is I'm going to let a be equal to x plus h, and I'm going to let b be equal to x. Okay, so when I substitute that, now I've got the limit as h approaches 0 of a to the n minus b to the n. Now this should look really familiar. Okay, so now I can substitute this in, so this is going to be really lengthy. So this is going to be the limit as h approaches 0. Instead of a to the n minus b to the n, I'm going to plug this long thing in up here. So I'm going to say a minus b times a to the n minus 1 plus a to the n minus 1, those are n's, not h's, times b plus dot dot dot, a to the b to the n minus 2 plus b to the n minus 1, all over h. Okay, and now to make things even more involved, I'm going to resubstitute in. So I'm going to resubstitute in this case. Resubstitute a for x plus h, and I'm going to resubstitute b for x. Okay, so when I do that, I'm going to end up with a limit as h approaches 0. Okay, instead of an a, I'm going to plug in x plus h back in. So it's going to be x plus h minus x. Okay, that's supposed to be a minus x in there. Okay, and then I've got x plus h to the n minus 1 plus x plus h to the n minus 1 times x plus dot 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 x plus h times x to the n minus 2 plus, okay, b here I'm going to have x to the n minus 1. Okay, and this is going to be all over h once again. All right, so in this first one, this was x plus h minus x. Okay, so x and x are going to cancel, so now I have an h out front. And the nice thing is these two h's are going to also cancel. So now I'm just left with this messy numerator. So I got the limit as h approaches 0. Okay, I've got x plus h to the n minus 1 plus x plus h to the n minus 1 times x plus dot 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 x plus h times x to the n minus 2 plus x to the n minus 1. Okay, so at this point I can substitute zeros in for h. So this is going to now be equal to x to the n minus 1 plus x to the n minus 1 plus dot dot dot. Okay, and then this is going to become x times x to the n minus 2 plus x to the n minus 1. Okay, so the only thing that's kind of messy at this point is this fraction, but this is a 1. So this is really x to the n minus 1 plus x to the n minus 1. Now, I can add these fractions. So n minus 2 plus 1 is x to the n minus 1 plus x to the n minus 1. Okay, so basically what will happen is these are all x to the n minus 1. And we know that there's going to be the number of terms that exist here are going to be same as the exponent. Okay? If you have a question on that, I can do that in explain that in class. So this is basically equivalent to n terms of this. So if you had 4 times 4 times 4 times 4, you have 4 of those, so you could write it as 4 times 4. So I have n of these, so I can write it as n times x to the n minus 1. Okay, so that is the formula for the derivative, is to take the exponent, bring it out front, and subtract 1 from the exponent.